You know that feeling when a grand building is finally finished, the ribbons are cut, the applause fades, and the architects move on to their next masterpiece.
Project complete.
For most of us, that's where the story ends, project done, right?
Yeah.
But for the building itself, and a truly crucial, often overlooked professional, the real long and complex story is only just beginning.
Hmm.
Today, in this deep dive, we're stepping into that next chapter, the vital world of facility management. We're going to fundamentally shift our perspective and explore why the facility manager, the person responsible for living with, operating, and maintaining a building throughout its decades-long life cycle, might just be the most important client of all.
It's a perspective change, absolutely.
Our mission today is clear. We want to uncover the profound and often surprising impact of design and construction decisions on a building's entire lifespan.
Yeah, those ripples go on for years. Decades, really.
You're going to learn how bringing the operations team into the conversation early is not just a nice idea, but a critical best practice for creating truly successful, sustainable, and even, well, intelligent buildings.
Critical, that's the word.
Think of this as your essential shortcut to understanding how buildings truly live, breathe, and evolve long after the last hard hat has left the site. We're going to unpack why a building's success isn't just about how it looks on opening day, but how it performs for 20 years down the line.
Exactly. The long game.
So let's unpack this idea of the facility manager as the ultimate client. It's so easy to fall into the trap of thinking a construction project wraps up once the keys are handed over and the first occupants move in.
That's the common view, yeah. Completion equals finished.
That's the common perception, isn't it? But our research really pushes us to challenge that, revealing a project life cycle that extends much, much further than just completion day.
Much for...
What we call the post-construction phase isn't an afterthought. It's explicitly defined as the period following substantial completion, signifying a recognition of a building's continued existence and very real operational needs. It's less like a finished painting and more like, I don't know, the birth of a living organism.
That's a good way to put it. It's a complete reorientation of how we think about a building's journey. Our materials describe the life cycle of a product, including buildings, as consecutive interlinked stages,
Okay.
beginning with raw materials acquisition and manufacture, and continuing with its fabrication, manufacture, construction, and use, and concluding with any of a variety of recovery, recycling, or waste management options.
Wow, that's comprehensive.
It is. This isn't just an academic definition. It's a profound shift in perspective.
Yeah.
It moves us from seeing a project as a finite delivery event to an enduring asset that lives, functions, and changes over many decades. And the facility manager. They are the absolute steward of that entire use phase, which, as you can imagine, is typically the longest and often the most expensive part of that entire cycle.
That's a huge shift in perspective. If we're talking about the entire lifespan of a building, not just its grand opening, then how do we redefine success for a building from this user-centric viewpoint? It can't just be about looking good on day one.
Precisely. No. Our research really pushes us to judge a building not on its initial sparkle, but on its long-term performance for the people who actually use and operate it.
Okay.
Think about it. A stunning building that constantly needs repairs, has temperamental systems, or is difficult for maintenance crews to access and navigate.
A nightmare scenario.
Exactly. Versus one that might be less flashy but seamlessly supports its occupants and operations for years with minimal fuss and predictable costs. Which one truly delivers value to the end user, to the business, to the community it serves?
Yeah, the second one, obviously.
That's the real success indicator. We're looking for operational efficiency, occupant comfort, safety, and long-term economic viability. These are the outcomes from the perspective of the customer or end user that genuinely drive value and define a building's true success.
This brings us to a really striking analogy that one of our sources uses, which highlights a critical gap in the industry. They call it the car analogy, explaining that new buildings are erected by individual contractors installing their respective systems. At project turnover, rarely are these systems and subsystems tested as a whole, living, breathing unit. The idea of a brand new car being delivered to you without ever having been test-driven is incredibly powerful.
It is a profound observation, isn't it? Imagine buying a brand new car, sleek and shiny, only for the manufacturer to hand you the keys, saying, "Good luck. We haven't actually test-driven this model to see if the engine, brakes, and steering all work together."
You'd be furious.
You'd be rightly furious. Yet in construction, that's often the reality. The facility manager or driver of the building inherits complex, disparate systems, HVAC, electrical, plumbing, security, that have been installed by different contractors,
Right.
often without truly being integrated, optimized, or even fully understood as a single cohesive unit.
So they left holding the bag.
Pretty much.
Yeah.
This immediate post-occupancy phase often leaves FMs scrambling to diagnose problems, optimize performance, and quite literally figure out how everything is supposed to work together in practice, long after the original designers and contractors have moved on.
Wow.
It's not just a burden, it's a tremendous legacy of fragmented decision-making.
So essentially, they're left to reverse engineer a complex machine they didn't build, and sometimes a machine that hasn't even proven it can run efficiently as a whole.
That's a recipe for constant firefighting.
That's exactly it. Constant firefighting. But for a moment, let's consider the other side. Are there any legitimate reasons why this test drive isn't happening more often in construction? What are the practical barriers to integrating these systems more thoroughly before handover?
That's an excellent question, and it really gets to the heart of some systemic challenges. Often it comes down to project timelines and budgets.
The usual suspects.
Yeah. Testing every system as a single living, breathing unit takes time, specialized expertise, and, well, it can add costs up front. In a competitive market, developers and contractors might prioritize hitting completion deadlines and staying within initial budgets, viewing extensive post-installation integration and testing as an additional expense rather than a critical investment.
Short-term thinking?
You could say that. There's also a lack of standardized processes for this holistic testing across the industry, and sometimes a disconnect in contracts where no single party is explicitly made responsible for the entire system's integrated performance.
So it falls through the cracks.
It often does. It's a complex interplay of short-term financial pressures and traditional industry practices that haven't fully adapted to the sophistication of modern building systems.
And who ultimately pays the price for that approach?
Well, the facility manager primarily, and by extension, the building owner and its occupants, dealing with those costs and inefficiencies over the building's entire operational life.
It's a clear case of paying now or paying much, much more later.
Precisely.
So we've established how thinking about a building's entire life cycle fundamentally changes our view of success. But how exactly do those initial decisions made years before a building even opens create ripples that impact a facility manager for decades? Let's start with something as basic as the materials chosen.
Foundational, really.
It seems even ancient builders understood the long-term impact of material choices. Our research actually brings up Vitruvius, for instance, and his surprisingly modern advice on bricks.
It's incredible how that ancient wisdom about bricks still resonates today, showing that material choices have always had long-term consequences. Vitruvius, writing centuries ago, provides remarkably relevant wisdom that any modern facility manager would appreciate.
Like what specifically?
Well, he advised that bricks should be made in spring or autumn and then dried for 2 years before using, even citing the example of Utica where they waited 5 years.
5 years? Wow, why so long?
His reasoning wasn't just anecdotal. He gave a very specific, almost scientific explanation for this foresight. When fresh, undried bricks are used in a wall, the stucco covering stiffens and hardens into a permanent mass.
Okay.
But the bricks settle and cannot keep the same height as the stucco. The motion caused by their shrinking prevents them from adhering to it, and they are separated from their union with it.
So what he's saying is, if you rush the drying process, the bricks will continue to shrink after they're installed.
Exactly.
The stucco, which hardens quickly, won't shrink with them, leading to cracks, delamination, and constant repair work for generations of facility managers.
You got it. That's a perfect illustration of how a seemingly small initial decision or oversight creates decades of headaches for those living with the building.
Decades of patching stucco.
Pretty much. It's not just about aesthetics. It directly impacts structural integrity, weatherproofing, and ongoing maintenance. Imagine the efflorescence, that white, powdery salt deposit that would perpetually appear as moisture moved through those unstable walls, or the constant need for stucco repairs.
Yeah.
You would be a never-ending battle for the FM. Vitruvius intuitively understood that material behavior over time dictates long-term performance.
That's fascinating how a choice about brick drying could cause such long-lasting problems. Bringing it into the modern era, the science of durability is still paramount. So if even Vitruvius was concerned about durability, what about modern materials like wood? What does the science tell us about building longevity versus future headaches there?
Wood. Yeah, the choice and treatment of wood is a prime example of where long-term thinking pays dividends for a facility manager. Understanding its inherent properties, particularly natural decay resistance, is absolutely crucial.
Okay.
For instance, the heartwood from species like redwood or bald cypress, especially the all-heart grade, is naturally resistant to decay and insects, making it a much more durable choice for exterior applications.
Makes sense.
But critically, the sapwood of these same species offers no more resistance than any other wood, meaning an FM would face premature rot and insect damage if the wrong part of the log was used or specified.
So you need to know your wood grades.
Definitely. And beyond natural properties, how wood is treated matters immensely. Using waterborne salts for preservation and then ensuring it's kiln dried after treatment for interior use directly influences its longevity and stability.
Right.
We even see the use of chemicals like polyethylene glycol or PEG 1000 for chemical stabilization. Think of it as a special treatment to minimize dimensional change in wood, essentially, stopping it from warping, cracking, and shrinking.
Which saves headaches later.
Which saves FMs a ton of costly repairs and replacements later on. These considerations directly influence the frequency and cost of future repairs and replacements, which, as you can imagine, are major budget items for any facility manager.
It's clear that everything from the smallest detail can have massive repercussions. Beyond the aesthetic or common sense choices, structural integrity is another area where early decisions become a facility manager's ongoing mandate. These aren't just details for the structural engineer, are they?
Oh, far from it.
Yeah.
They become the FM's daily reality. Decisions about concrete mixes, masonry strengths, the specific type of fasteners used for joists, or the methods for reinforcing connections directly bear on a building's structural integrity over its lifetime.
Like the specific nails or hangers used.
Exactly. Our sources detail the importance of very specific nail spacing for structural panels or approved joist and framing hangers. These aren't trivial details that can be skimped on. If these fundamental elements are compromised by poor initial choices or shoddy construction, facility managers don't just face aesthetic issues. They face costly, complex, and potentially dangerous maintenance challenges.
Yeah, safety becomes a big concern.
Huge. They have to constantly monitor the building's fundamental safety and stability, potentially needing expensive, disruptive retrofits. Consider how brittle solids, like brick and glass fracture. Understanding these material properties influences how design can mitigate fracture, or, at the very least, design for easier, less costly repairability when damage inevitably occurs.
Right.
The ongoing tuning up of an existing building becomes a much more involved and expensive process when the initial structural choices are not robust, directly impacting the long-term value and safety of the asset.
Beyond just materials, how systems are designed and integrated can truly make or break a facility manager's ability to, well, manage the facility effectively. HVAC systems, for instance, are incredibly complex, the true lungs of a modern building.
Absolutely. Central nervous system almost.
How do design and placement decisions here echo through decades of operations?
Oh, profoundly. The design and placement of HVAC components profoundly affect everything from energy consumption and occupant comfort to the ease and cost of maintenance.
Everything.
We're talking about everything from the fundamental layout of ductwork and radiant panels to the accessibility of individual thermostats and crucial balancing valves.
Those little valves matter.
They really do. If these components are difficult to reach, poorly labeled, or their access points weren't considered in the design, imagine a valve hidden behind a permanent wall, then routine maintenance can become a major undertaking. This drives up labor costs, increases downtime for critical systems, and can lead to deferred maintenance, which only compounds problems.
Right.
Furthermore, the choice to integrate smart electrical grid capabilities with local renewable energy systems, for example, sounds wonderful on paper.
Sounds great.
But it requires sophisticated modeling tools during design and meticulous integration in the field. If that integration isn't flawless, the facility manager inherits a system that is incredibly challenging to manage and optimize for energy efficiency on a daily basis,
So it backfires.
effectively negating the entire green intent and tuning an asset into a liability.
So it's not just about what's inside the walls, but also the building's skin and how it breathes. Roofing and the entire building envelope seem like areas where small details can lead to enormous long-term problems. What should designers be thinking about here from an FM's perspective?
They absolutely are. The building envelope is the first line of defense, and seemingly small details can have monumental, decades-long consequences for the FM.
Like what kind of details?
We're talking about things like ensuring proper soffit vents and ridge vents for roof ventilation, crucial for preventing moisture buildup and extending the roof's life, or the meticulous application of flashing and sealants to ensure air barrier continuity.
Air barrier continuity.
Yeah.
Okay.
These aren't just minor architectural notes. They are absolutely critical for preventing long-term issues such as condensation, insidious mold growth that compromises air quality, and significant energy loss as conditioned air escapes and unconditioned air infiltrates.
Mold is a big one.
Huge. Our sources specifically emphasize that air barrier continuity is important, especially where interior walls intersect exterior walls, where attic ceilings intersect exterior walls, at window and door openings, and at service penetrations, such as electrical outlets and plumbing penetrations.
So basically everywhere things connect.
Pretty much.
You get
You see, every single penetration, every seam, every corner is a potential point of failure where air and moisture can infiltrate. If these details are overlooked or poorly executed during construction,
which happens.
which unfortunately happens,
Right.
the facility manager will be perpetually battling air leaks, water intrusion, associated damage to finishes and structure, and perpetually inflated energy bills for years to come.
Wow.
It's a classic example of how a few $100s saved in construction can cost tens of thousands in maintenance.
This also circles back to the practical reality of maintaining these systems. If you can't get to something, you can't fix it easily or safely. Designing for access seems like a fundamental but sometimes forgotten principle that can cause huge headaches.
It is absolutely fundamental and often, shockingly, forgotten until the FM is facing a crisis.
Like what?
A direct example comes straight from building codes. The requirement that roofs and penthouses containing elevator equipment that must be accessed for maintenance are required to be accessed by a stairway.
Makes sense. A ladder seems dangerous.
Exactly. This isn't about creating grand aesthetics. It's pure, unadulterated maintainability and safety. Imagine the cost and danger if maintenance crews had to rappel or use specialized lifts just to reach an elevator motor room for routine checks.
Yeah, no kidding.
To draw on a historical example, even Palladio, centuries ago, recognized the practical implications of stair placement. He sometimes tucked internal stairs away for less frequent use, while external stairs served a design function greater than in any previous domestic architecture by leading directly to main living floors.
Interesting.
These historical and modern design choices directly dictate how easily and safely facility managers can access and service critical building systems. Poor access translates directly to higher labor costs due to increased time and specialized equipment needed, longer repair times for critical systems, and potential safety hazards for maintenance personnel.
Got it.
Ultimately, it significantly impacts the building's operational efficiency, cost effectiveness, and overall lifespan.
Speaking of safety, it's not just about the structure itself, but also the crucial life safety systems within a building. These are the systems that protect occupants and property in emergencies.
Absolutely critical systems.
What are a facility manager's ongoing, high-stakes responsibilities in this critical area?
Facility managers bear immense responsibility for the ongoing operation and maintenance of vital life safety systems. This isn't a one-time check, it's a continuous mandate.
Continuous,
Yeah.
right.
They're responsible for ensuring the constant functionality of emergency voice alarm communication systems, the intercoms that direct people during an evacuation. They must maintain firefighting command centers, which are the nerve centers for emergency responders.
Okay.
And they rigorously oversee standby and emergency power systems, which must be fueled by a 2-hour supply of on-site fuel to ensure critical systems remain operational during power outages.
That 2-hour fuel supply is specific.
It's often a code requirement. These systems are not merely for emergencies. They require constant monitoring, periodic testing, and meticulous upkeep to ensure they will perform exactly as designed when lives depend on them.
High stakes indeed.
Very high stakes. FMs must also understand the difference between passive fire protection, like the fire-resistant walls and floors built into the structure, and active protection, such as sprinkler systems and smoke detectors.
Passive versus active?
Right. Their mandate is to ensure the integrity of those passive elements, that fire doors still close properly, for instance, and the continuous, reliable functionality of active systems. This is a continuous high-stakes responsibility directly impacting occupant safety and building resilience.
And all of this is regulated by a complex, ever-evolving web of codes and standards. How does a designer's initial understanding or even misunderstanding of these codes impact the facility manager long after construction is complete? It sounds like it could create legal and operational nightmares.
It's absolutely a huge issue, and it can indeed create significant legal and operational burdens. Designers must familiarize themselves with the applicable edition of the model codes for the specific jurisdiction where the building is located,
Because they vary.
because variations between cities, counties, or states can, and often do, lead to a lack of code compliance when the building is finally occupied. What might be acceptable in one city might not be in another, and designers need to be acutely aware of those nuances. When a building is designed or constructed without this precise attention to local codes, the facility manager inherits that compliance burden.
They get stuck with it.
Exactly. They are then responsible for remediating non-compliant systems, which can be incredibly costly, disruptive, and time-consuming. Sometimes it even requires significant retrofits or operational changes to bring the building up to code years after it was meant to be finished.
Years later, wow.
Our sources even highlight how specific thresholds for occupancy groups, like a 2,500 square foot limit for F1 food processing establishments, can drastically change applicable code requirements.
Tiny details, big impact.
Any misclassification or oversight here becomes an ongoing, legally mandated headache for the FM, underscoring the vital need for meticulous adherence and foresight during the design and construction phases. This isn't just about avoiding fines, it's about safeguarding lives and the long-term viability of the building.
We've talked extensively about how critical long-term thinking is and how past decisions echo through a building's life. So how do we fix this traditional disconnect between design, construction, and operations? It seems like early engagement and team collaboration could be the crucial answer to building truly high-performance buildings.
That's precisely what our research overwhelmingly suggests. The traditional design bid-build model often creates silos where crucial knowledge isn't shared across the project lifecycle.
Right, everyone in their own box.
Exactly. Designers finish their work, contractors build, and then the FM is left to figure it out. However, what's identified as absolutely crucial for high-performance green building delivery is initial team building, which engages the widest possible range of stakeholders.
Widest possible range.
Yes. This means proactively bringing in the people who will actually live with the building, including the facility managers, community members, and even local building officials, into what our sources call the charrette process during the design phase.
So a charrette isn't just a fancy word for a meeting. It's an intensive collaborative workshop, right? Bringing everyone, even the future facility managers, into the room right from the conceptual stage.
Exactly.
Spot on. What's the real benefit of such an intensive early collaboration?
The real benefit is immense. This proactive, collaborative approach helps to minimize the potential for changes after the building is constructed because you've caught issues and optimized for long-term operations before anything is built.
Catching things early saves money.
Saves a lot of money and headaches. It also creates a space to approve any innovative out-of-the-box solutions that might otherwise be rejected by more traditional processes or later stakeholders who weren't part of the initial vision.
Okay. Encourages innovation, too.
It does. It's about front-loading intelligence and foresight, baking those future operational insights and user perspectives into the design from day one, rather than trying to bolt them on as an afterthought, which is almost always more expensive and less effective.
Yeah.
This shifts the paradigm from reactive problem-solving to proactive value creation.
And this early engagement isn't just for conceptual design. It extends to ensuring the building actually performs as intended, particularly with complex mechanical systems. This is where commissioning comes in, right? It's not just a final checklist, but a process that needs to start early.
Absolutely. Commissioning is not an afterthought or a final tick box. It's a foundational element that needs to be integrated from the very beginning. A project commissioning plan must be created prior to the start of design.
Before design even starts.
Yes, the stakes here are incredibly high. A green building may be carefully designed and engineered to deliver superior energy performance, but little of this sustainable feature will come to fruition if the mechanical systems have not been installed, programmed, and balanced correctly.
So all that green design could be wasted.
Completely wasted. This is where long-term performance meets the road under the watchful eye of the facility manager. If systems aren't commissioned properly, meaning they're not installed, tested and fine-tuned to meet the design intent. The FM inherits a building that underperforms, consumes excessive energy, and often creates occupant discomfort,
Right.
effectively negating the entire investment in high-performance design. The commissioning process, when started early, ensures accountability and verifiable performance for the entire lifespan of the building.
So it proves it works.
It's about verifying that the building actually does what it was designed to do, rather than just looks like it can.
All of this sounds like a lot of information, a lot of coordination, a lot of different moving parts. So how is technology, specifically the digital revolution, helping facility managers navigate this increasing complexity? Building information modeling, or BIM, is often mentioned, but it seems like it's much more than just a 3D drawing tool these days.
Here's where it gets really interesting and transformative. You're right. BIM is far more than a 3D modeling tool. It's accurately described as a database-driven modeling system that is designed for collaboration.
Database-driven, okay.
The key insight is that each element within the BIM file comes with information attached. That information can include construction details, performance characteristics, product specifications, warranty information, maintenance schedules, and even the manufacturer's contact details.
So everything about everything.
Pretty much. This comprehensive integrated data is absolutely invaluable for facility managers. It provides them with a living, dynamic database for maintenance, troubleshooting, planning future upgrades, and even space management.
A living database. I like that.
Contractors already use BIM for coordination, clash detection, estimating, 4D CAD, which integrates scheduled data to visualize construction progress, and
It
procurement.
makes construction smoother.
Right. This reduces errors and changes during construction, leading to a much smoother, more predictable handover. And critically, our sources point out that links between BIM components and owner control systems, such as maintenance or facility management, will facilitate the commissioning and handover process to the owner at the end of the project.
So BIM talks to the FM systems.
Ideally, yes. It's essentially a digital twin that guides the building's entire operational life, turning what used to be stacks of paper manuals into an interactive, intelligent resource.
So BIM provides the blueprint and the manual for the building's entire life, but it's constantly updated, which is fantastic. But the vision doesn't stop there. We're also seeing the rise of what our sources call sensible cities and truly intelligent buildings, moving beyond static models to dynamic, responsive environments. It sounds almost like the buildings themselves are starting to think.
That's a perfect way to put it. The next frontier involves embedding digital elements in physical space. This transforms buildings from inert structures into intelligent agents with the capacity to learn from and coexist with their occupants.
Whoa. Learning buildings.
You can envision a future, and in many ways it's already here, where we are shifting from living in a home to living with a home, where buildings become active interfaces in our environment, constantly gathering data, understanding our patterns, and even anticipating our needs.
Anticipating needs.
Yeah, this isn't just futuristic speculation, it's happening now. These intelligent buildings, enabled by ubiquitous sensors and networks, facilitate a truly dynamic and adaptive relationship with their environment and occupants, moving beyond just automation to actual intelligence.
That's a profound thought. From living in a home to living with a home, it suggests a much more symbiotic relationship. Can you give us some tangible, almost futuristic examples of this data in action? How is it shaping how buildings are managed and how we experience them on a daily basis?
Certainly. Think about the Internet of Trash project.
Internet of Trash.
Yeah, it mapped waste disposal patterns to optimize the entire waste management system for a city that's a powerful metaphor for managing building systems. In an intelligent building, ubiquitous sensors and networks are enabling predictive maintenance, where equipment issues can be anticipated and addressed before they lead to costly failures.
Preventing problems before they happen.
Exactly.
Yeah.
Imagine a building's HVAC system constantly adjusting ventilation and temperature based on real-time occupancy data and air quality rather than a fixed schedule.
Much more efficient.
Or maintenance schedules being dynamically generated based on actual component wear and tear rather than arbitrary fixed intervals. This data-driven approach moves facility management from reactive problem-solving to proactive, intelligent stewardship.
Right.
It drastically improves efficiency, significantly reduces operational costs, enhances occupant comfort, and can even contribute to better health outcomes by optimizing air quality and lighting.
So real benefits for occupants too.
Absolutely. You might have your office automatically adjust to your preferred lighting and temperature the moment you badge in, or a meeting room pre-cooling itself 15 minutes before your scheduled meeting. It's about creating environments that respond to you.
That sounds like a truly dynamic, adaptive approach to architecture and management. It almost echoes the principles of cybernetics, which our sources also touch upon the idea of self-regulating systems.
It very much does. This concept of cybernetics, when applied to architecture, means negotiating a set of interrelated factors such that they function as a dynamic system.
Negotiating factors.
Instead of designing a building with fixed outcomes, where everything is rigidly determined, designers are increasingly moving towards being choreographers of dynamic and adaptive forces.
Choreographers, I like that.
This means creating environments that can learn, evolve, and respond to changing conditions and occupant needs over time. It's a profound philosophical shift from seeing buildings as static monuments to understanding them as living, breathing, responsive entities that constantly interact with their surroundings and inhabitants.
And the FM is central to that.
The facility manager becomes integral to this choreography, guiding the building's adaptive journey, using the data to make informed adjustments and keep the building finely tuned. They're not just maintaining a structure, they're curating an experience, hashtag tag trade 3.3, towards continuous improvement and resilience.
This dynamic, almost cybernetic perspective leads naturally to the idea of continuous improvement. How do facility managers, armed with all this new data and a collaborative mindset, ensure a building is constantly getting better, adapting, and even learning from itself?
This is where established management frameworks like PDCA, Plan-Do-Check Act, and the Last Planner system become incredibly valuable, moving from theory to tangible practice.
PDCA, right.
These are methodologies about learning from experiments and continuously improving plan reliability. For facility managers, this means an iterative process of planning maintenance tasks, executing them, meticulously checking their effectiveness, and then acting on that feedback to refine processes and optimize building performance.
So constantly tweaking and learning.
Exactly. For instance, analyzing why a planned maintenance task wasn't completed on time or why a system unexpectedly failed helps improve future planning, resource allocation, and even inform design changes for future projects.
Feeding back into design,
Yeah.
closing the loop.
Precisely. This constant feedback loop is essential for FMs to continually enhance efficiency, reduce operational costs, adapt to evolving occupant needs, and ensure the building remains at peak performance throughout its long life. It's about treating the building's operation as a continuous improvement project.
And as we consider the long lifespan of a building, especially in a world with rapidly changing climate conditions and technological advancements, it's not just about efficiency, but also about its ability to withstand change and unexpected challenges. We're talking about resilience, a building that can take a punch and keep on ticking.
Precisely. Resilience is key. Buildings, like all complex systems, need to be managed not only for productivity or stability, they also need to be managed for resilience. This means designing and operating buildings that can adapt to changing needs. Environmental conditions like more extreme weather events, which are becoming increasingly common, and rapid technological advancements.
Future-proofing, basically.
In a sense, yes. A truly resilient building can absorb disturbances, recover quickly from shocks, and even evolve its functionality, ensuring its continued usefulness and value over many decades.
Right.
For the facility manager, this involves anticipating potential risks, implementing robust preventative maintenance strategies, and having the flexibility to adapt systems and operations. It's about building in redundancy, future-proofing infrastructure, and having contingency plans, all informed by that ongoing data collection and continuous improvement cycle.
This concept of buildings as dynamic, evolving entities rather than static objects is beautifully captured in the idea that architecture in its material nature and in its animating essence is a plastic art. What does that really mean for how we think about buildings, and specifically for the FM?
It's a poetic, yet profoundly practical notion. If architecture in its material nature and in its animating essence is a plastic art, it suggests that buildings are not fixed, unchangeable monuments meant to stand frozen in time.
Not just statues.
Exactly. Instead, they're meant to be shaped, molded, and adapted throughout their lives, much like a sculptor works with clay. This aligns perfectly with the facility manager's role. They're not just maintaining a static asset, they're actively participating in its continuous shaping and refinement, ensuring it remains relevant, efficient, and resilient as needs change.
So the FM is kind of like the sculptor.
In a way, yes. It empowers the FM to be an active agent in the building's evolution, rather than just a caretaker. It asks designers to think not just about the initial form, but about the building's capacity for graceful change and adaptation over its long, complex life.
Ultimately, All of these considerations, materials, systems, safety, data, collaboration, and continuous improvement, boil down to long-term value. How do we justify the initial investment required for these high-performance, resilient buildings, especially when upfront costs can sometimes be higher?
This is where life cycle costing is the key tool for justifying the decisions to create a high-performance building. It moves the conversation beyond just the initial construction cost to the total cost of ownership over the building's entire lifespan.
Looking at the big picture financially.
Exactly. Studies have clearly demonstrated that total 20-year savings significantly outweigh the initial additional investments required for green buildings.
Significantly, like how much?
Well, for example, some initial studies indicated that added costs for LEED certification might be around 2% for silver or gold levels.
Okay, a small percentage increase.
Right. But the total 20-year savings were on the order of $50 to almost $70 per square foot for an initial additional investment of only about $4 per square foot.
Wow, that's a massive return on investment.
Huge. This robust economic argument reinforces the facility manager's long-term value proposition. By investing wisely upfront, guided by the FM's operational perspective and focusing on durability, maintainability, and efficiency, developers and owners can achieve substantial savings in energy, water, emissions, and even reap significant health and productivity benefits for occupants over the entire life of the building. It's an investment in enduring success, not just a flashy debut.
Makes perfect sense when you look at it that way. Hashtag outro.
We've journeyed through the crucial, often underappreciated world of the facility manager, understanding how their long-term perspective fundamentally reshapes our definition of a building success.
It really does shift things.
From Vitruvius's insistence on properly dried bricks to modern BIM models and ubiquitous sensor networks, every single decision made at the drawing board echoes through a building's entire life.
Every single one. Designing for maintainability isn't just a best practice. It's a core tenet of responsible, sustainable construction, ensuring that buildings not only look good on day one, but perform exceptionally for decades, delivering true value to everyone who interacts with them.
Absolutely. Value over the long haul.
As technology advances and our understanding of systems deepens, what new opportunities arise when we stop seeing buildings as static objects delivered at occupancy and instead as dynamic learning partners we live with for decades? How does this profound shift impact everything from urban planning and material innovation to individual comfort and the very definition of architecture itself? What new skills and collaborations will be needed to truly bring a building's long-term potential lovingly into being? And how will our cities evolve when every building is designed to be a living, adapting entity?
Big questions, exciting questions for the future.